Hello everyone. So this is the introduction to our class 11th K mathematics. So today we'll start with the basics concepts of maths for JE as well as the board. Okay. So here our first unit is function. Okay. In which we're gonna learn about the number systems. So let us start now. Okay. So let me. Okay, maths class 11. We'll start with the unit function. In that, first we'll learn number system. Okay, so in that, first is natural numbers. Okay, so the set of numbers like 1, 2, 3, 4 are called natural numbers, and it is denoted by n. So n is equals to 1, 2, 3, 4, and goes up to infinite. This is your natural numbers. Second, we'll write about the integers. Okay, so the set of numbers like -3, -2, -1, 0, 1, 2, 3 are called integers, and it denoted by I or Z. Okay, so we can write I or Z, which is -3, -2, -1, 0, 1, 2, 3, and goes on. Correct? Now, positive integers. Positive integers, which is denoted by I plus. So these are 1, 2, 3, 4, and goes on. These are your natural numbers also. Next is negative integers, that denoted by I minus, that is your -4, -3, -2, and -1. Okay. Non-negative integers, which will include your 0, 1, 2, 3, 4. Okay. So these are your whole numbers also. Non-positive, which will include -3, -2, -1, and 0. Okay. So this is all about the natural numbers and the integers. Okay. So can note down this first. Okay. So next is rational numbers. Rational numbers. Okay. So all the numbers in the form of a by b, okay, where a and b are integers and b is not equals to 0 are your rational numbers. And their set is denoted by q. Okay, so we can write q is equals to a by b such that ab belongs to integer and b is not equals to 0. Okay, so this is about your rational numbers. Okay, next is irrational numbers. So those values which either terminate nor could be expressed as recurring decimals are irrational numbers. That means it cannot be expressed as form of a by b form and are denoted by qc. Okay, that is complement of c, complement of q. Okay, so examples: root 2, 2 plus root 2, 1 by root 2, minus 3 by root 2, 2 by root 2, root 3, 1 plus root 3, plus minus 1 by root 3, and etc. Even your uh, pi, e, etc. Okay, so pi and e are called special irrational quantities. Okay, and infinity is neither a rational number nor a irrational number. Okay, this you need to remember. Okay, next comes to your real numbers. So the set which contain both rational and the irrational numbers are called your real numbers. Okay, which is denoted by r. Okay, and that is we can write it as r is equals to q union of qc. Correct. So that if we define the range, we can write it from like this. Correct. By the definition. So positive real numbers will be 0 to infinite. Negative real numbers will be minus infinity to 0. All real numbers except 0, which will be not. So that will be minus infinity plus infinity and excluding your 0. Okay. So note down these 3 points about the rational numbers, irrational numbers, and the real numbers. So I think I had copied. Next is imaginary numbers. So that is denoted by C, and that is your I, omega, and etc. Okay, and there are prime numbers, which you already know. Okay, those numbers that are natural numbers greater than 1 and divisible by 1 and itself only. Okay, so your example 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on. Okay, so this was all about your numbers. Okay, so next I will start the intervals. Okay, so we can write set of numbers between any two real numbers is called interval. Okay, so here first is closed interval, means that will include your values. We can denote it as A to B. Okay, that means this is including your A and B. Next is open interval. So that will not include your B, A and B values. Okay, so that is okay. And one more is there, which is semi-open or semi-closed interval. This, suppose A to B. Okay, so that means X is including your A only including A, and it is X is including only B, not A. Okay, so you can note down this. So now, next, let's start with the functions. Okay. So let A and B two given sets, and if each element A belongs to capital A is associated with the unique elements of B belongs to capital B under a rule of function, then this relation is called the function. Okay. Meaning f of A to B. Okay. So there are two conditions. Every element of A should be associated with B, but vice versa is not essential. Okay. Next is every element of A should be associated with unique of B, but element of B can have two or more two or more relations in B. Right. So if this is defined on the real values, then it may be called as real valued function also. Right. We can write a real valued function. Okay. Now let us start with the representation of function. Representation of function. Okay. So it can be done by three methods. By mapping, by algebraic method, and in the form of the ordered pair. In the form of ordered pairs. Right. So we'll see one by one. Okay. So first start with the mapping. Correct. So it shows the graphical aspects of the relation of the elements of A with the elements of B. Okay, what does it mean? Suppose a function f1 having set a, set b. So there are numbers, some elements a, b, c. Here p, q, r. So a corresponds with p, b with q, and c with r. So this is your f1 function. Now let's look at another one, f2. Again, the same thing. This is your a, this is your b. This time we are having four elements. Here w, x, y, z. A with w, b with x, c with y, and d may also with y, z may be empty one. Next is a, b, c. Here we can write like 1, m, and 0. So a with 1, b with m, c may have two values, m and n and 0. One more mapping. So that is your a, b, c, u, v, w. So a with u, c with w. There may be no relation between b and v or and with any subsets of the b. Okay, so let's finalize all these four functions. So mapping rule f1 and f2 shows a function because each element of a is associated with the unique elements of b, whereas f3 and f4 are not function because in f3 element c is associated with the two elements of b, right? And in f4, if it's not associated with elements of b which do not follow the definition of function. So in f2, c and d are associated with the same elements, still obeys the rule of definition of function, because it does not tell that every element of a should be associated with the different elements of b. So I hope now we are clear. Again, I'm repeating the definition. Let a and b, two given sets of each element a belongs to a associated with the unique elements b belongs to b under a rule of f. So then this relation is a function. Two notes I have given. Okay, note a and note b. You can check out those and find out the mapping for the functions of f1, f2, f3, and f4. Okay, you can make a note for this. Next is algebraic method. Algebraic method. So it shows the relation between the elements of two sets in the form of two variables x and y, where x is independent variable and y is your dependent variable. So if A and B two given sets, sets A 1, 2, and 3, and B is 5, 7, and 9. Okay, so then function A to B, which is y of fx, will be for such like 2x plus 3. So all these values will be containing. Okay, next is in form of ordered pairs. In form of ordered pairs. Okay, so a function f a to b can be expressed as a set of ordered pair in which the first element of every ordered pair is a member of A, and second element in the member of B. So F is a set of ordered pair AB such that your three conditions: A is an element of capital A, B is an element of capital B, and the third is two ordered pairs should not have should not have same first element. Same first element. Okay, so these 3 points can copy. First is A is an element of capital A, and second is B is an element of capital B. And the third one is two ordered pairs should not have the same first element. Okay. Next is your testing of a function or testing for a function. Testing for a function. Okay. So a relation f a to b is a function or not. It can be checked by the following method. Okay. So like relations are given different methods. Okay. So as we are learned from the mapping, algebraic methods, all these you can use. Other than this, there's a vertical line test. Vertical line test. Okay. So if we are given a graph of the relation, then we can check the whether the given relation is a function or the not. So it's possible to draw the vertical line which cuts the given curve at more than one point, then the relation is not a function, and the vertical line means parallel to y-axis which cuts the curve at only one point, then it's a function. Okay, suppose, so given this, so this is your one example, second one, this third one, okay, fourth one. So with that definition you can check out, right? Okay, so again I'm repeating, if we are given a graph of the relation, then we can check whether the given relation is a function or the not. So if it's possible to draw a vertical line which cuts the given curve at more than one point, then the given relation is not a function. And when it's the vertical line means which is parallel to y-axis cuts the curve at only one point, then it's a function. Okay. Okay. So as this was your introduction class, okay. So let me highlight some points here, okay, regarding your maths, okay, for the as well as the board. Okay. So first, let's discuss about the algebra. So no other topics can come close to the algebra in the simplicity and ability. Okay. So what's required from the applicants to have high computational speeds and clarity about the basic concepts. Okay. So like it's algebra is considered as one of the most interesting topics. Okay. It includes your topics like differential equations, probability, complex numbers, PNC, quadratic equations and expressions, matrices and determinants, progressions and series, binomial theorem, and sets relation and functions. Okay. Then we come to our calculus. Okay. So mostly students are fear of this parts only about the calculus. Okay. So problems that have their base in theory as well as the problems that are their base in applications, okay, which comes under the calculus. First is your differential calculus, which includes your limits and the continuity, applications of derivatives as well as the differentiation. Then integral calculus, which includes indefinite integral, definite integrals, and area under the curves. Then we move to the coordinate geometry, which will include your straight lines, parabola, hyperbola, circles, ellipse. Then the remaining part will be trigonometry. Okay, so this is about your maths. Okay, so we'll solve problems, we'll do examples, we'll also take previous year problems, board problems. Okay, so one by one we'll do. Okay, so we continue from the next lecture. Okay, so thank you guys.